So good morning to all. Today we can discuss about the minimum shift keying in wireless communication. Minimum shift keying is a spectrally efficient modulation technique, and it is one of the most useful mobile radio communication system modulation technique. It is a special case of continuous phase frequency shift keying, wherein the peak frequency deviation is equal to 1 by 4 the bit rate of, and the modulation index should be equal to 1 by 2. So it's a special form of FSK, which provides smooth transition from space frequency to mark frequency or mark frequency to wave frequency. Because in FSK we use two distinct frequencies, one for logic 0 and one for logic 1. Here the phase discontinuities will be there. This can be overcome by this MSK. So the my MSK can also be set to as continuous phase FSK. So the principle of FSK is based on this model, that is continuous phase frequency shifting with modulation index 0.5. So we know that the bit error rate of that particular FSK that is the modulation rate should be 2 del f by RB. It should be equal to 0.5. So what should be the del f? It is nothing but the frequency deviation. So which can be written as 0.5 RB by 2. So del f is equal to RB by 4. So that the frequency deviation will be varying from 1 by 2 del and minus 1 by 2 del. So Fc plus del f. So the value is equal to Rb by 4. So it will be 1 by 4t because Rb is equal to 1 by t. So the frequency will vary from plus 1 by 4t or minus 1 by 4t. It is 1 by plus 1 by 4t be for symbol 1 and minus 1 by 4t for symbol 0. So this thus the space and mark frequency depends on the bit duration. It changes from one frequency to another frequency, and it is another way it is specialized as offset, a special form of offset QAM. So OQAM, which is half sinusoidal waves with the duration of 2t. So 1 by 2 into 1 by 2t becomes 1 by 4t. So it can also be represented as an offset QAM. So there are certain properties of MSK. So what are the major properties of MSK? It is satisfying is one is constant envelope. That means there is no amplitude variations. We have a constant amplitude. Second one should be good BER performance, which is related to the spectral efficiency. The power spectrum of this particular MSK is going to be given with a very low bit error rate. So we have good BER performance. Third one should be self-synchronizing capability. That means the transmitter and the receiver, there is no special synchronizing mechanism for separately for transmitter and receiver. So it is represented mathematically as root of 2 EB by TB cos of 2 pi FCT minus M I of T M Q of T. That is in phase and quadrature pi T by 2 TB plus pi K. So as you have continuous phase shift, phase as well as changing, the frequency as well will be changing. The frequency will be changing from my Mi of T, MQ of T, pi T by 2 TB, and pi K is nothing but your change in frequency, sorry, change in phase. So it will be separated at the time instant from 0 to, it will be starting from t equal to 0 and subsequently varies up to the duration. So automatically it is going to be varying with plus or minus. So MSK transmitter. So for two input sinusoidal waves, one carrier signal should be cos pi FCT and another one should be cos 2 pi T by 4 pi TB. So first should be producing two phase coherent sinusoidal waves at frequencies F1 and F2, which is related to the carrier frequency Fc plus 1 by 40 and Fc minus 1 by 40 by using the bandpass filter. These two FSK signals are then separated from each other by two narrowband filters centered at F1 and F2. One should be considered to be the in-phase component and another one should be the out-of-phase component. Then it should be literally multiplied each other and then summed together, which will be producing X of t. That X of t will be the modulated signal with respect to the in-phase, and the Y of t represents the out-of-phase. So the bandpass filter is designed to have the Fc plus Fb by 4 or 1 by 4t as well as Fc minus 1 by 1 by 40 or Fc minus Fb by 4. These two constraints should have to be satisfied. And then it should be summed together with respect to the Mi of t and Mq of t. Both should have also the bit rate is equal to 1 by 2 into TB. The outputs of the multipliers are then added in order to give you an MSK modulated signal. So the MSK waveform is obtained with the continuous phase throughout the time interval as well as the data transition. Then it follows the MSK receiver. This MSK receiver, you have it is detected either non-coherently or coherently. In this diagram, first it will be shown with the coherent detection. In this, the received noisy MSK signal is correlated with the locally generated replicas of the same reference signal X of t and Y of t, which will be used in the transmitter sign. And then it should be given to the resulting in phase and quadrature will be given compared with the threshold of 0. So threshold of 0 estimates the phase only. Here we are going to estimate only the phase. Either it should be theta cap of 0, that is your Mi of t, and theta cap of Tb, that is your Mq of t. Finally, these phase decisions will be given to reconstruct the original signal with a minimum average probability of symbol error. So this MSK will be a very relevant and very much important technique which is used in your MSK technique. So bandwidth of MSK is similar equal to 1.5 FB, which is higher than your QPSK signal. So this is the power spectrum. This power spectrum shows this MSK is having a higher spectral efficiency compared to the QPSK and OQPSK because it is a particularly which is having a low raised cosine filter ratio, which will be discussed in your GMSK also. But here it is having a highly spectral efficiency value because it is having a main lobe of MSK is containing 99% of energy, whereas QPSK main lobe contains only 90% of energy. So the main lobe is occupying, see this, the main lobe is occupying a very higher efficiency level compared to the others. Side lobes are going to be get reduced. So this is the power spectrum of this. And there are some certain disadvantages. One is side lobes. That's what I told you. There are several side lobes, even though it is having a higher spectral efficiency. And the next one should be less spectral efficiency because of this, because we are using a bandpass filter, and in order to avoid inter-symbol interference due to the side lobes, we will be requiring filtering or bandpass filtering. So that we will be having these things. This advantages of MSK, which we have discussed in the same case, continuous phase, smooth signal, and the constant envelope. So the MSK band waveforms are smoother compared to the QPSK, and it's continuous phase in all cases without any variations in your amplitude. And the third one should be the wider. Main lobe of the MSK is wider. That is the major disadvantage. Okay. Then the disadvantages should also be highlighted. But even though we have higher bandwidth requirement of MSK, it is very much higher than the QPSK. So it should be somewhat design should be complex in the generation and detection. Thank you.